Okay, Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. My name is Muhammad Hari Azri bin Zamzuri. And now I'm going to explaining about my project, which is Snell's Law Simulator. First of all, I would like to explaining about the physics concept behind this simulator. First of all, what is refraction? So refraction is a bending light, the bending of light when it passes from one medium to another due to the change in speed. So as we can see here on the picture is one of the example where the straight line look bended through the glass of water. So why does this light bend? So light travel at a different speed in different media. So when light enter a new medium at an angle, its spin change, which this change in speed cause the direction to also change. So what is the relation with this Snell's law? So as we can see on this equation is n1 is sin theta 1 equal to n2 sin theta 2, which n1 is a refractive index of medium 1 and n2 is a refractive index of medium 2. So what is this refractive index? So basically this refractive index is the capability to bend the light of some medium. Okay, here is my Snell's law GUI, which we can see here. I put a photo, which I use the label and input the photo here using the label, and then I put the text field where we can insert the incident angle, source index of n1, and target material. I use the combo box, so we can choose between several material. And then I have put the calculate button and show graph button, and also I put some n value reference here. So without further ado, let's go to the source, the button from here, the calculate button. So this is the coding I do for the calculate button to calculate the refracted angle. So it takes the input from the two incident angle source and source index n1, and then it also read the combo box selection here, and then it will calculate the refracted angle, which will be appear here. Okay, so let me run here, run the file real quick. As we can see, I put the incident angle which 90, the source index is 1, and the target material is water. So water has a 1.33, which means the lower part here will be the n value for water. So let's see the calculation. So from the air, which incident angle is 90 degree, and as we can see, it bended here, which show that the refracted angle is 48.75 degree, which when it bended to the water. And then if we can see, if I change to the glass, which have a higher n value, it will slightly bended more, which refracted angle turn into 41.81 degree. And if I choose diamond here, then it will refracted less, which give us a refracted angle of 34.41 degree. Here, what happened here is for the show graph button, I put some coding here where it's firstly read the material and so on, and then I make this pop up. So when I click the show graph, it will pop up a new tab. So let's see. Let's say I want the incident angle to be a 45 angle and this water. So supposedly it will give a 32.12 degree, and the bending light should be like this. So let's see the graph. So for water, we can see sin theta 1 versus sin theta 1 here versus sin theta 2 here. We can see that the relation is linear. So I would like to change to the glass now. So let's see. So the graph, as you can see, is slightly lower than the water one because glass have a higher n value. And then if I do diamond, I show graph, and we can see that for the diamond, the graph become much more lower as it have a higher n value, which show that the relation between this incident and refracted angle is linear to each other. Alright, so let's go to the bottom one. So this is where I code for the drawing panel for this ray diagram and also this graph. So for the ray diagram here, you can see that I code for the size, the color, the incident ray, the color of incident ray, the refracted ray, the color of refracted ray. And then this is for the graph where I use the same method, but I just add the pop-up from the show graph button I mentioned earlier. So here the same way, I put the height, put the axis, and then I put the number, the levels, and the y-axis, and then the graph, the scale of the graph, and the loop. And also I put some restriction here where it will stop, the graph will stop working if the internal reflection is impossible, which sin 2 is lower than 1.0. So that's all from me. Thank you.